All right, guys, so as a kind of culmination to all this stuff that we've been looking at for the polynomial functions, we're going to graph this function right here using all of our techniques. Now, we can always graph things like this if we just kind of, oh, let's plug in some values for x, find some points and plug all the points in and everything. We could totally do that. But there's a whole lot less, there's a less tedious way to do this, and we can do it in ways that we kind of recognize things about the function and kind of use those things to our advantage and kind of be able to use those things that we can find out about the function to graph it, as opposed to just plugging in x values and seeing what happens. So let's see what we got. First off, let's find the zeros of this thing. So let's do x cubed minus 2x squared equals 0. And then so we can factor this out. Let's see, looks like we can take out an x squared. So x squared times x minus 2 equals 0. Now, a little tip to finding the zeros. I would write this x squared as x times x minus 2. And I'll show you why in a second. Because now when we set it up, it's going to be x equals 0, x equals 0, and then x minus 2 equals 0. Okay? Writing it as x times x kind of helps to see that that shows up twice. All right? So there's one 0, there's another 0, and then we get x plus 2, and there's our 3 zeros. Okay? So our zeros are 0 and x equals 2, sorry. And so our zeros are 0 and 2, and 0 has a multiplicity of 2. So multiplicity of 2. Right? So now let's go ahead and graph this thing. So let's put it over here. Here's our xy axis. And so we have zeros at 0 and 2. So here's 0, and we'll say 2 is like right here. There's 1 right there. So now what do? How do we graph this thing? So here's this. Now the first thing we can look at is well, we have our first thing we just did. We put our zeros on there. But now when we actually start to graph the thing, let's think about end behavior. What would the end behavior of this graph be? We come back over here. We look at our leading term right here, our x cubed. It's an x cubed. It's a positive x cubed. So that means it's going to have the same end behavior as the regular x cubed one did, which it's going to be down and up. That's what the end behavior is going to be. So we start from this first point here, and we go down. We go to this second point, and we go up. That's what the end behavior is. And it's never going to touch the axis again after this. So it's going to go down, it's going to go up. There we go. We have our end behavior. All right. But now the question is, how do we connect these dots? What do we do in the middle? We have kind of a couple choices here. Let's go off and make a few little choices over here for us. So we have here and here and here and here. This is what we have right now. We've got this going on. The choices we have are, we can go up over the x-axis, curve down, touch it, and bounce off. Or we could bounce off here, curve down, and go up through this way. So we either go up over the x-axis or we come down under the x-axis as we kind of connect here to here. So which one do we do? Do we go through 0 and bounce off 2, or do we bounce off of the 0 and go through the 2? Well, now that's when we look at our multiplicity. The 0 has a multiplicity of 2. That means 0 has an even multiplicity. So at 0, if you remember what even multiplicity means, that means it's going to bounce off the graph at that 0. So at 0, it's going to hit it and bounce off. So it looks like we're going to have this scenario right here, not that one. All right. So it's going to come up, bounce off at 0, come down, curve back up, and there you go. All right. And so that's going to be our graph, and that's our finished graph of this thing. Okay, and that's what we can do. Okay, using all those different techniques that we had. First off, find the zeros. The zeros correspond to the x-intercepts. Then, depending on the multiplicity of, then we can figure out what the end behavior is. And then to kind of connect the dots in the middle, we look at what the multiplicity of each one is, and we see, do we cut through or do we bounce off? Right? Put all those things together, and there we go. And that's how we graph things. All right? And that's how it works. Good deal? All right.